everybody? Hope you can hear us. Can somebody just put the usual thing, just put a comment in the box, just to make sure that the sound's working all right? Hopefully it should be. It's coming up with all the bars there. And if you can hear me, the light's flashing on the microphone, so I assume it is working. Brilliant. So we just put yes, excellent. Right, so just before we start, make sure that you've got hold of this sheet. If you have, then brilliant. If you've done it already, that's even better. If you haven't though, click on the link in the description box. You'll be able to get a hold of it there. And what we'll do, as usual, we'll go through all the questions and go through the answers and make sure you kind of you get all the answers. What I've done on the bottom of this one instead is I've actually put a total out of 28. It's just at the bottom there, so you can add it up as you go along and see what you get. Some tricky questions in there actually. It requires you to know quite a bit of information about that, about the kinetics topic. If you haven't already, it might be too late now by the looks of it, but this video is obviously linked with the kinetics content video that we did on Tuesday. That is on the YouTube channel, so it's all on there. But so they're designed to link basically. But if you've done year 1 chemistry already, then you can just use this as revision. Right, so we're going to start in about 10 seconds or so, just to make sure we've got enough people, or people have arrived on time. I hope you found these. Okay. These questions. I know they can be quite a little bit tricky. Right. Okay. So what we're going to do, I'm going to make a start. Soon as though the screen's working, camera's working, microphone's working, everything's working. I'm here and you're there, so that's brilliant. Right. So let's have a go. Let's see if we can do the first question. Mark them as you go along. I'll tell you how many marks. Well, the number of marks are on the paper, but I'll tell you where the marks are attributed to until the answers and see how far you get on them. Okay, right, so let's have a look at the first question. That's not a good start. That doesn't seem to be working. There we are. Right, so the first question was all linked to the kinetics video if you'd seen it on Tuesday. So everything on there you'll be able to answer the questions in here. Some of them are a little bit trickier. There's some little extra bits as well, but you should be able to do this. Right, so the first one is, explain what is meant by the term collision frequency. Okay, so frequency is to do with how often something collides. Obviously, collision is to do with a collision, as it says. So the answer to this one should be the number of collisions between particles per second. Okay, so if any of you do physics, you'll know about frequency. It's always measured per unit time. So normally it's per second. So in this case, it's the number of collisions between particles per second. That's all it means. Okay. Give yourself a mark if you've got that, or somewhere in the region of the number of collisions between particles per second, so anything like that should be fine. Okay, so, and like I say, if you're a bit stuck, I know you've done this in the past, we've done a few of these now. If you get a little bit stuck on one of the answers, or you're not sure if it's right, just drop it in the chat box, and I'll make sure it's all right, or see if it actually works. Okay, right. So the next question number 2. Is explain what is meant by the term collision energy. So this one is using a slightly different terminology, but it's for 1 mark. Now questions like this on the exam are normally these 1 mark questions. They want you to write down key words. Okay, that's the key thing. That's the most important thing is being able to write these key words down. So terminology is king. So the collision energy. Okay, so this is the combined energy of the colliding particles. Okay, so this is the amount of energy released when particles collide. Okay, so it's the total amount of energy that's released from that. Okay, so that's your collision energy. Give yourself a mark if you've done that. Okay, and the last one of this part is explain what is meant by the term activation energy. Okay, so you would have seen this definitely in the video. I talked about activation in Tuesday's live lesson. I talked about activation energy quite a lot. In terms of the maxwell-boltzmann distribution, and we looked at energy profile diagrams as well with the humps in them. So we talked a lot about activation energy. So activation energy is the minimum amount of energy, or collision energy, however you want to phrase it. So the minimum amount of energy required for a collision to be successful. Really, really, really important. You must write down the word minimum is very important. and successful collision is important there as well. Okay, so really important terms in there. Okay, it's the minimum amount of energy. You must put that. If you just put the amount of energy, you won't get the mark. Okay, the word minimum is quite important. Okay, so that's out of 3. Okay, so we're going to go on to look at part B. Okay, so hopefully that should be alright. Nobody's putting anything in the chat, so that's fine. So I assume these must be okay. Right, so let's look at part B. Now this one was for, there you go. So this one was for 2 marks for this one. Okay, so give 2 examples of how these can be changed in a chemical system. So in other words, how can we change collision frequency? How can we change collision energy? And how can we change activation energy? So I'm just looking for 2 examples. It doesn't really matter, but you can give an example for each if you want. You're still only going to get 2 marks because it only asks for 2 examples. Okay, so just remember that. So your answers are, let's look at collision frequency first. Remember, frequency is the number of collisions of particles per second. Okay, so it's how many collisions there are. So how can we increase the number of collisions? Well, we can do that by changing the pressure or the volume. So basically, if we take a container, so you've got a box like this, and we squash that box, we've got the gas particles in there, they're going to be much closer together. So your frequency of collision is going to increase, isn't it, if we're squashing that box? Changing the concentration, that's going to change the obviously the frequency of collision. So if we lower the concentration, that's going to make the chance of these particles colliding much lower, and if you increase the concentration, it's going to make it higher. Changing the temperature as well means you've given it more kinetic energy, so you're heating them particles up, they're moving around with a lot more. It's like these particle discos, they're moving around with a lot more energy, and so therefore they're more likely to bump into each other because they're running around, well, not running around, they're moving around furiously because you're actually heating them up. So anything like that, if you wrote down anything like that, give yourself a mark. Okay, so another one, collision energy. If you decided to pick collision energy as one of your examples, then collision energy can be changed by changing the temperature, basically. So if you give the particles a lot more energy, they're going to collide with a lot more energy. Remember, that's just as important as frequency. They need to have enough energy for them to react as well. Okay, can you explain how we draw the Maxwell-Boltzmann diagram, please? There were some questions where asked us to draw the shift curve. Yes, the Maxwell-Boltzmann question is going to come on after this. Okay, so I'll show you on there. All right. Okay, and the last one, if you were talking about activation energy can be changed by adding or removing or changing a catalyst. So remember, a catalyst is the only thing which can change the activation energy. Okay, so you just need 2 of them. Any 2 of them. If you wrote any 2 of them down, you give yourself 2 marks. Okay, so there's plenty of things there that you could write. So you probably, if you cast the net wide enough, you'll get your 2 marks there. Okay, so if you add all them up, that should be 5. So question 1 was out of 5. So how did you do? If you put your score on the bottom if you have done it. It was quite fairly straightforward. They were all just definitions, which you are going to get in the exam. Definitions are quite important. It's just trying to make sure that you've done enough. You've done enough revision to make sure you're getting them keywords in there. Okay. Right. Okay. So what we're going to do is we're going to move on to question 2. So appreciate some of you might not have actually done these questions in advance. You might be just doing them or sitting going through them as I'm talking through them. So that's fine. Right. Okay. So let's look at question 2. So this was related to the person who's just put in about Maxwell-Boltzmann curves. This is where we're going to be looking at it here. Okay. So question 2A, part 1 or part I. So it's sketched with the first few answers. Okay. So somebody's put 3 for 3. Okay, that's good. Okay, so 2A part 1. Sketch the Maxwell-Boltzmann distribution of molecular energies for a low temperature, which is T1, and a higher temperature at T2. 3 marks involved here. Now, Maxwell-Boltzmann, you're looking for very specific features of these curves, and you've got to make sure that you're hitting them. Okay, so when you're drawing them out, the examiner is looking for certain features in your curves. Okay, somebody's put 4. Okay, so you put 4. I think there's a bit of a lag on the feed here. So somebody's got 4. Okay, so Ryan got 3, Alex got 4. Okay, brilliant. That's a pretty good score out of 5, so that's pretty good. Right, okay, so just look onto the Maxwell-Boltzmann. So you've got to make sure you're drawing these curves properly, okay? So the answers I'm going to bring up the curves, and then I'm going to put up the criteria in which you score marks on, okay? Now, these are dead easy to get marks on. They give you loads of marks. You just got to make sure you're putting in the right things, okay? So your Maxwell-Boltzmann, if you've done this, okay, if you've done this question, you should have curves that look something similar to this, okay? So you should have T1, which is your lower temperature, a little bit higher up, and T2 is your higher temperature, and that's shifted a little bit further to the right. So you should have a curve that looks like that. And the marking criteria is you get 1 mark for drawing your T1 peak must be to the left and higher compared to T2. So if you see on here, you can see that T1 is a good bit higher, there it is there, and it's to the left of the peak of T2. So as long as you've done that, then give yourself a mark, okay? It's your first criteria. That's the first thing. The second mark is your T2 curve. This is your one at a higher temperature here. Crosses the T1 curve once. Okay, so it'll cross it here, as you can see there. So it never meets towards the end here. It's always higher, okay? And it always must start at 0, 0. Remember, because no particles have 0 energy. Okay? So that's your second mark. And then your third mark is going to be both peaks or both peaks must not touch the x-axis. So both peaks, should I put an S on there? Okay, so both peaks must not touch the x-axis. So the x-axis is that bottom axis, remember, at the bottom, they must not hit the bottom of that. They always must be slightly elevated from that, okay? If you've got all of that and you meet that criteria, then you've just got yourself 3 marks. It's dead easy, literally drawing lines. Okay, 3 marks for drawing lines. Okay, we're looking for that criteria. So that criteria is going to be standard across all exam boards. Okay, you need to be able to make sure that you're drawing your curves correctly and accurately as well, instead of just drawing them, randomly on the axes. Okay. So remember, just as a reminder, with the higher energy one here, so this is your higher energy curve. This one sits lower, but remember the the area under both of these peaks is the same. Okay, this one's got a higher peak over here. This one's a lower peak, but the area is the same underneath the white curve as it is the red curve. Okay, remember the area underneath. I might be giving answers away for the next questions, to be honest. Remember the area underneath is the number of particles. We're not changing the number of particles. What we're doing is changing the amount of energy that these particles have. Okay, that's what the Maxwell-Boltzmann distribution is telling us. It's telling us about the energy. What energy do these particles have? Okay, rather than the number of particles, because the number of particles is the same. So give yourself 3 marks if you got that right. Okay, right. So I haven't got any questions so far on that, so I'm assuming that everybody's fine with that. So I'm just going to move on to the next question. Okay, so the next question is explain what happens to the mean kinetic energy. So we're referring to the Maxwell-Boltzmann distribution graph. Okay, so what we need to be comparing is as we're moving from T1 to T2, what's happening to the mean kinetic energy of the particles in this system here. So the answer will be on moving from T1 to T2. So in other words, we're heating the particles up. We're going from a colder to a hotter scenario. Okay, the kinetic energy increases as the particles are moving faster. We're heating up that container. Remember, we've got a gas container here. Imagine you've got gas particles. We're providing them with heat energy. We're heating them up. They're going to move around with a lot more energy, and so therefore they're going to move a lot faster. Okay. So 1 mark. Make sure you give yourself a mark if you got that right. Okay, so the mean kinetic energy increases, okay, because the particles are moving faster. So make sure you put that. You've got to state that they're moving faster. Okay. Right. Next one. No problems with that, I don't think. Okay, so let's do the next one. So again, referring to your Maxwell-Boltzmann distribution, so we're really kind of digging into the finer details of the Maxwell-Boltzmann. This question is designed to do that anyway. So explain what happens to the area under the graph. Okay, so this is for 1 mark. Be careful, because this might seem like a little bit of a tricky question, okay, for this one. So remember, what I said before, your graphs, the area under tells you the number of particles. Now, all we've done here is we've just heated the particles up. We haven't added any particles, and we haven't taken away any particles. We've just provided them with more energy. So the areas under the graph is going to be exactly the same, okay? We haven't changed the particles. Just remember that. They're probably going to put something like this in, and you'll think, oh, something must happen. Something must be, the area must increase or decrease. Well, actually, it doesn't, okay? So it may seem like a trick question, but it's really... Examiners put questions like this in to really test your understanding and your knowledge of this area of chemistry. Okay, so give yourself a mark if you've got that, and well done for getting that mark as well, because that's quite a tricky question. Okay. Okay. So assume we've got no questions on there. That should be fine. Okay. Right. So let's move on to the next question. Okay, so explain what happens to the number of particles having the most common amount of energy. Okay, so the one which is going to be the most common, remember there's a difference between average energy and the most likely or most common amount of energy on your graph. Okay, so what happens when we're moving from T1 to T2, so we're heated up, okay, the number of particles having the most common amount of energy decreases. So remember, there's a greater spread of energy. So remember that peak. You've got that really tall peak there. I wonder if I've got my diagram here and I can show you. There we are. Okay. So you can see on that graph there. Okay. So you've got a really tall peak here. Yep. And then you've got a broader peak down here. So you can see that is the most common energy at the top of these peaks here. But as we heat that up, the energy, you can see the peak drops. Okay. So it's a lot lower. So the number of particles with the most common amount of energy decreases. Okay? It's just my answer sheet. Okay, so give yourself a mark if you've done that. Again, that's another tricky question. I think the key thing with Maxwell-Boltzmann is to not understand the difference between average energy, which is just to the right of the peak, and the most common energy, which is at the peak. Don't get the two confused, okay? Got to remember that. Okay. So I think that's the... okay, no. So there's one more part. There's part B after this. Okay. So give yourself a mark if you've done that. Okay, and then the last part. So this is part B. Well, not the last part of the lesson, but the last part of this question. So part B. Hence, from that information, explain why an increase in temperature has such a large effect on the rate of reaction. Okay, so if we increase the temperature, why does our rate of reaction significantly increase? So we're looking for 3 marks here. So this is quite tricky. So they're clearly after a lot of information with this one. Okay, so is the 2019 chemistry paper out? I'm not sure. I'm not sure if it is. You might want to have a look. Depends on your exam board. Go and have a look at your exam board, and you should be able to find it on there if it's AQA, OCR, Excel, etc. Right, okay, so let's have a look. The first mark is 3 marks. The mean collision energy increases, okay? So in other words, the amount of energy that we've got in these particles, because we're heating them up, okay? The amount of energy that they have is now increasing. That gets you 1 mark. So you're commenting on the amount of energy of the particles. So be methodical with your question, okay? Okay, so next one. So the chance of having a collision of energy greater than the activation energy is much higher, okay, because they've got more energy. Okay, the collision energy increases, so they've got more energy. So therefore, the chance of them colliding with enough energy to react is going to be a lot higher because they've got a lot more energy. And then the last mark, so the third mark is so the fraction of successful collisions is going to be a lot higher. So you're going to get a higher proportion of your molecules. Imagine you've got 100 molecules in that box and only 5 of the molecules in that box have enough energy for them to react. So most of them don't react. They'll bump into each other. Remember what we looked at in the live lesson on Tuesday. We said that when particles react like that, they don't actually react. They'll collide, but they don't react because they don't have enough energy, or they might not be in the right orientation. There's all sorts of different reasons for it. And they might not have enough energy to react, so they'll just kind of bounce off each other and then move apart. Particles with a little bit more energy, so heat energy, means that now instead of just having 5 particles out of 100 with enough energy, you've now got 10 or 15 particles. So a higher proportion of your particles in that box have got enough energy for them to not only collide but react when they do collide. And so that's the really important part, that last point. So the fraction of successful collisions is a lot higher. Okay. So give yourself 3 marks out of all of that. That's out of 9. Okay. So that's the that's for that question there. Okay. So that's question 2. So give yourself a mark out of 9. And then drop your scores in there, and I'll move on. As you put your scores in there if you've done it. But okay, so let's move on. Let's move on to question 3. Okay, hopefully this is not too bad. That's quite a tricky question. That again, what the examiners look for. Just before I move on to question 3, what the examiners are looking for here is your ability to break down what's happening. Be methodical with your answer. So you're saying, and you might be thinking that you'll know this, but you need to communicate this with the examiner, otherwise you might lose marks. Questions like this, some people will probably get 2 marks because they'll miss out. They'll miss out about the fraction of successful collisions is much higher. Okay, questions like this, you're following the same type of order. You talk about the energy. Okay, more energy in there, higher chance for collision, and so therefore there's a higher fraction of successful collisions because you've got more particles with more energy, with energy greater than the activation energy. Okay, 8s, 9s, 10s. Wow. Okay, 10. I don't think you can get 10. I was going to say it's just been message retracted. So yeah, it's out of 9. If you got 9, it's very, very good. Okay, excellent. Okay, so let's have a look at question 3. Okay, so question 3 is explain the meaning of the term catalyst. So remember, the catalyst bit in this topic is a little bit dodgy because it depends on which exam board you're doing. Now, for most cases, the lesson that I did on Tuesday is suitable for all exam boards. It's just for some of you, you'll not do it. So, for example, if you're doing AQA or OCR, some of the catalyst stuff there you'll not do, like homogeneous catalyst, for example, you'll not do until year 2. So you do need to know it. It just, you might not be familiar with it if you've only done year 1 chemistry. So there's a few different things here, but we're looking for the meaning of the term catalyst. This is a classic exam question. It comes up so many times, and it's always it's always worth 2 marks, depending on the exam board, but generally it's worth 2 marks because there's 2 important points about a catalyst. Okay. Okay, so I missed the mean energy increasing. Yeah, so Ryan, mean energy increasing. If you're heating something up, okay, imagine you've got an average energy. Let's say if we put a value of 10 to it, just any number. So if you've got a box of particles and they have an average energy of 10, if we heat that up, there's more particles that will get will get more energy, so the average energy might increase to 11. So it'll increase. So overall, on average, the particles in that box have a little bit more energy because you've heated them up. Okay? Hope that helps anyway. I hope that it helps to explain. Right, so meaning of a catalyst is, first mark, a substance which changes the rate of chemical reaction. That is critical. We're talking about kinetics here. We're talking about rates of reaction, so you've got to put in there rates of reaction. Brilliant. Okay, well done, Ryan. Okay, so a substance which changes the rate of chemical reaction, really important. And if you've done loads of past papers and you're doing year 1 chemistry, you'll probably be screaming the answer to the second one. Catalysts are not used up. They're chemically unchanged. Okay, so you're always left with, if you do a chemical reaction, whether it's a heterogeneous or a homogeneous catalyst, whatever catalyst you're using, it's always the same at the end. So you do your reaction and you'll always get your catalyst back at the end. Okay, give yourself 2 marks if you got that one right. Well done if you did. Okay, it's that last bit, really, really quite tricky. Loads of people know that catalysts speed up the rate of reaction. It's that bit at the bottom. Okay, don't lose that mark. So it's easier said than done, isn't it? Okay, so give yourself 2 marks. Right, so let's look at 3B. Okay. So explain how a catalyst lowers the activation energy for a reaction. Okay, so this is 1 mark. So this was looking at in Tuesday's lesson where we looked at the energy profile diagrams for catalysts, and we had our reactants and products, and we had our rise and then it drops. Okay, and then your homogeneous. If you do Edexcel, you'll know about homogeneous. If you don't, then you'll need to. If you do AQA or OCR, you'll need to know that in year 2 chemistry. So you will need to know it eventually. But homogeneous, you've got this kind of intermediate in the middle. If you're not sure what I'm talking about, go and have a look at the video on Tuesday. It's all on the channel. So for 1 mark, is a catalyst lowers the activation energy of reaction by providing an alternative route. You can use pathway depending on what you want to say. Either's fine for the reaction. Okay, so a catalyst is providing an alternative route. So if you imagine that diagram, your normal route is going up, like up the rise. Whereas if you have a catalyst, it's not as high. The rise is a lot shallower. Okay. Okay, so give yourself a mark if you got that. Okay, that's a pretty standard question. Okay. Right, okay, so let's move on to 3C. Okay, so use the Maxwell-Boltzmann distribution of molecular energies. Wow, just a Maxwell-Boltzmann curve will do. So basically, Maxwell-Boltzmann distribution of molecular energies to explain how this leads to an increase in the reaction rate. Okay, so we've got 2 marks here. So we need to be talking when an examiner or exam paper or question or whatever is asking you to use something, you must refer to it. If they've given you a diagram and they want you to use the diagram or refer to it, please refer to it. Okay, please make comment to it or make it obvious that you are referring to the diagram, because they're not putting diagrams in for no reason. They're wanting you to use it. Okay, so this question, we're not actually, obviously we did have a Maxwell-Boltzmann previously, but we need to be referring to the Maxwell-Boltzmann in this example. Okay, so looking for specific things. So the first bit, 2 marks, first bit, if the activation energy is lower, okay, the number of colliding particles with energy greater than the activation energy will be higher. Okay, so remember you've got that on your Maxwell-Boltzmann, you've got the activation energy that's tucked well over to the right hand side. Okay, if the activation energy is lower, then we've got more particles on the other side of it that have energy greater than the activation energy. Okay, so just visualize that Maxwell-Boltzmann curve in your head. So remember, you've got activation energy and it's moved further forward. Okay. How does homogeneous catalyst lower the time taken to complete the reaction? Normally, your homogeneous reactions are normally for species that wouldn't normally react together. So, for example, 2 negative ions trying to react together is a classic example. But it does that really by it speeds it up, because you don't need as much energy to actually allow this reaction to occur. So it goes faster at a lower energy. Okay, so that's basically how it works. All catalysts lower that activation energy, and it speeds up. Hence, by default, it then speeds up the rate at which it's produced as well. Okay, hope that helps. Right, so just back onto this one. So that's your first mark, and then your second mark is so the fraction of successful collisions will be higher. Okay, so we're making reference to the Maxwell-Boltzmann by talking about the activation energy line being lower down that curve. Okay, it's further to the left hand side of your chart. Okay. Could you just write energy equal or greater than the activation energy? Yes, you can. Yep, that's fine. Yep, so it's equal to, that's fine. Equal to or greater than the activation energy. You've got to, remember it's 2 marks though. I think you might be referring to one of the points, which is fine. But you must say, so the fraction of successful collisions will be higher. You must put that bit in there as well to get your second mark. Okay? Right, okay, so give yourself 2 marks for that one. Right, so this that question was out of, that's question 3 done. So that's out of 1, 2, 3, 4, 5. It's out of 5. Okay, so drop your scores in the I was going to say scores in the doors. Drop your scores in the chat if you've done that. So that's out of 5 for question 3, and then what we'll do is we'll move on to question 4 afterwards as well. Okay. So some quite tricky questions there. They're all difficult, aren't they? I'm not going to give you an easy one. 3, 4. Okay, that's good. I guess a good mark here. Seriously, if you're getting 3s and 4s and towards that there's a 3 there, brilliant. If you're getting scores like that, that's pushing on 75-80%. There's a mixture of more straightforward questions, a mixture of difficult questions in here as well. So if you're pushing for scores like that, then you're knocking on for getting B's and A's and A stars if you do A level. So so that's really good. That's really good. Okay, so let's move on to the last question, which is question 4. Okay, so this was tricky. Okay, this was tricky. Now, this is where you really have to have a really kind of a good breadth of knowledge. Okay, I know OCR like to use the terms of breadth, like breadth, how much knowledge you actually know, rather than actually refining it, which is you got breadth and depth. So this is all about your kind of vision of knowledge. Okay, so you might not be able to get all the marks here. You're doing exceptionally well if you do. This is a tough question to get all the marks on. But for each of the following reactions, so there's going to be 3 reactions. I've split them up into separate slides here. But for each of the following reactions, list 3 ways in which the rate of reaction could be increased, and we've got that reaction there. I'm just going to come back to this. There's a question on here. So how does adsorption take place in a homogeneous catalyst? It doesn't. Okay, adsorption only happens in heterogeneous, because heterogeneous is a solid. It's basically heterogeneous catalyst is a catalyst that's a different phase to the reactants and products. Okay, so heterogeneous catalyst, you have a solid base like that, and you have reactants that kind of attach onto it, and then you have another reactant that'll attach on the other side. They'll react and then leave the catalyst. Okay, homogeneous catalysts are not solid based. They're aqueous. They're in the same phase as your reactants and products, and they behave in a different way. They actually react directly with the substances, and that's why you get this intermediate. I hope that helps. Yes, it does. Brilliant. Okay, good. Yeah, so adsorption only with heterogeneous catalysts. Okay. Right, so this equation here. So for each of the following reactions, list 3 ways in which the rate of reaction could be increased. Really, really, really important, because chemists need to know how to make products quicker, particularly in this current environment with COVID-19 and coronavirus. So where chemists are rapidly millions and millions and millions of pounds and dollars and whatever currency you're using is being pumped into research to try and develop a vaccine or drugs or medication to try and eradicate the virus. So trying to make this virus or trying to make the vaccine, we have to know how to make this so quickly, okay? Because it's time critical, because it's taken people's lives. So chemists are developing methods and ways in which they can develop a drug, and if they can manufacture it really quickly, it means that it can benefit the end user, because it means you can churn out a lot of these per day. So this is a really, really, really important thing, especially in this environment. It's all about speed and time, and so this is very relevant. So we've got this reaction here. Key thing here, when they ask questions like this, is you're looking for state symbols, okay? You're looking for certain things. What are you producing? What do you have? So here you can see that we've got a solid, we've got a solution here, which is your acid, okay? Hydrochloric acid, there it is. We've got calcium carbonate, which is a solid, and we're producing our gases here. So we need to be thinking along the lines of what we can do to some of these substances. So these are the 3 that you're after. So you get 1 mark for each. So a higher temperature would increase the rate of reaction. Greater concentration of hydrochloric acid would do that as well, and smaller particle size of magnesium. If we turn that from large chunks into a powder, okay, that's not going to be magnesium. That should be calcium carbonate, not magnesium. Okay, there's the first typo. That should be calcium carbonate. Okay, so smaller particle size of calcium carbonate. So in other words, you take that solid and you grind it up into a powder, and it speeds up the rate of reaction. Larger surface area. There's a higher chance of reactions happening if you've got a larger surface area. Okay, right. No further questions on that. So give yourself 3 marks if you got all 3. You're doing very well if you're doing that. Okay, because this is tricky. Because this is not just saying, recall what you can do to speed up a reaction. You have to actually look at this equation and apply your knowledge to something which you haven't seen before. That is quite high. That's what we call high order thinking. Okay, right. Can you say addition of a catalyst? Yes, you could. Yeah. Yep, you could. Yeah, you could put addition of a catalyst. That's fine. Yeah, that'll be absolutely fine. I didn't put that on, but that's fine. Brilliant. Okay, right. So let's look at part B. This reaction here. There it is. Okay, exactly the same, but this time we've got H2 gas plus I2 gas will form HI gas. This is going to be obvious, isn't it? This is going to be, we've got gases here, okay? How do we know which way a reversible reaction goes by increasing the temperature? Right, okay, so we're getting into enthalpy there. Basically, just to keep it keep it simple because we might go a little bit off topic here, but you're looking for, if you have a reaction, okay, at the end of your reaction, this one's for Omar, but at the end of your reaction, you have an enthalpy value. So if it's a minus value, minus 300, let's say, at the end of your reaction, what that's telling you is the forward reactions is exothermic. If the value next to the reaction is positive, let's say it's plus 300 kilojoules per mole, then it's telling you the forward reaction is endothermic. Now, if the forward reaction is endothermic, the reverse reaction's got to be exothermic. Simple as that. I hope that helps. Right, okay, so 3 points, 3 marks, 3 things you need to put here. Any of these 3 will do. A higher temperature is fine, okay. Higher pressure is quite relevant because we're dealing with gases here, okay, so pressure is relevant here. Greater concentration of hydrogen, so if we have more hydrogen there, greater concentration of iodine will do. And of course, a catalyst will be fine there as well. Okay, so catalyst would do the same. Okay. What they might do in the exam, because you could apply catalyst to any of these, is they might say, apart from catalyst, state 3 ways in which you could, I should have put that, shouldn't I? Apart from saying catalyst, state 3 ways in which you could increase the rate of reaction. Okay, right, so give yourself, if you got any of them, give yourself 3 marks. Okay, and then the final one is part C. There we are. Okay, so for each of the following reactions, list 3 ways in which the rate of reaction could be increased. Okay, so we've got hydrogen peroxide here, it's aqueous. We're forming water and we've got oxygen gas being produced. So this is a decomposition of hydrogen peroxide. Okay, and then so anything such as higher temperature, increase of the temperature would speed up the rate of reaction. Okay, greater concentration of hydrogen peroxide. Okay, so increasing the concentration of that, or an addition of a catalyst will do there as well. Okay, so give yourself 3 marks if you got any of them 3 there. Right, okay, so add all that up, the total, because that's all the questions, so the total should be out of 28, I think. Yes, it's out of 28. So mark it out of 28, put your scores in the thing. That'll be, some people have put 3, that's brilliant. If you're getting anything like that, that's absolutely brilliant. That, so give yourself a mark out of 28. You'll be doing pretty well. If you're getting anything in the region, well, anything above 20 is a pretty good score, I would say. There's some tricky questions in there. There's some easier ones. There's a good mix of different questions. So put your scores in there. Let's see what you've got. I don't think there's any questions coming through at the moment. I think you've done very well to ask some questions in there. 25, brilliant, excellent. Yeah, anything above 20, and you're doing particularly well with some tricky questions in there as well. Right. Would you mention the first answer quickly? I wasn't here. Yeah. What I do, Ryan, is the answer. Let me just see. First answer, right. Let me just skip back. It might lag a little bit, that's all. Okay. I'll put this up. There you go, Ryan. There's your first one. Okay. Why does temperature increase the rate of reaction if we only have gas in the product? Same reason. If you increase the temperature of a gas, the particles move around a lot more. They have a lot more kinetic energy, higher chance of collision, and higher chance of a successful collision as well. Okay. So that's the reason why. Brilliant. Okay. Right. You might have seen the comments and the kind of community bit on the channel. This will be the last live lesson that I'm doing. Unfortunately, I did this because I've been furloughed from work, so now I've been asked to go back to work and my full job. So I've done this just while I've got a bit of extra time, which I won't have much of when I go back to work. So this will be the last one. So I hope they've been useful, and I hope they've been informative. There's loads of stuff on the channel. I've been working away, updating it and adding extra stuff on there, and there's still been stuff being added on there. Starting from now, there's AQA stuff, exam board specialist stuff. The black revision videos. You've got OCR, Salters, EdXL. There's the lot. They're all tailored to the exam board. So if we're doing any of them, that'll be fine. CIE will come on later, because I know some people have been asking for that, and there's the whiteboard tutorial as well. So there's loads of stuff on there, and all these live ones go on to the YouTube channel as well. I think it takes YouTube about 24 hours, I think, to get it sorted. I don't know what they do with it, but they put it on. So, brilliant. So, thank you very much for kind of sticking with it and joining in the spirit of it. You know, I hope it was useful. You know, it's obviously got loads of different elements to the content and the questions, etc. But the key thing is you make sure that you go through these exam questions. You know, go through them. They're absolutely invaluable. You'll get all your marks. You know, if you revise and go through questions, keep going through questions. Get into the habit of knowing what examiners are after, because if you get into that habit there, you're going to just absolutely rack the marks up, and that's how you're going to get your grade. Okay, brilliant. Okay, so no, that's no problem. That's absolutely fine. You know, there's loads of stuff on there. Like I said, there's loads more going on there. It's all for free. Just hit the subscribe button. If you see all my other videos, you know, I say keep hitting the subscribe button, because you know, it just shows, you know, if the people keep subscribing and watching, I'll keep making them, and as the syllabus updates, I'll update them as well. So brilliant. Okay, let's hope your motivation, exam skills, all that's good. Helpful teacher, that's brilliant. No, that's good. No, it's anything, you know, if it's no good, you know, chemistry being in my head, it needs to be, you know, shared out so you can do something with it. So be the next generation of chemists. Right, okay, brilliant. All right, thank you very much for your time, and I'll definitely, you know, if we've got a bit more time, I might do more of these in the future. It just depends. Obviously, it's been an unusual time, but yeah, there's loads of stuff on there anyway. I'll keep updating the communities tab as well and putting updates on there and keeping in touch. All right, brilliant. All right, thank you very much for your time anyway. Okay, see you later. Bye bye.